And new friendship, thanks a bunch. Monday's gravitational wave observation is astronomical alchemy. If you are wearing a piece of gold jewelry, take a good, hard look at it and consider this: you are likely to be wearing the celestial debris of a cataclysmic stellar collision, a collision so devastating that it literally shook the universe. That's the conclusion from Monday's announcement of gravitational wave signal GW170817. It is another reminder that we are intimately connected to the cosmos around us. At heart, astronomy is not really about remote and abstracted realms. Instead, it informs us about our own origins and the origins of those things we value. Astronomically, the origin of gold has been a puzzle for decades. The recognition that stars shine because they fuse one chemical element into another was made in the 1920s. It suggested that stars are the chemical factories that build almost everything in the chemist's periodic table, but the details were elusive. Astronomers have since established that the simplest elements, hydrogen and helium, were made during the origin of the universe in the fireball of the Big Bang. The rest of the naturally occurring elements come in various quantities from dying, exploding or colliding stars. Monday's announcement confirms research from 2013 that shows that a significant fraction of the gold and other heavy elements could come from the collision of two super-dense celestial objects known as neutron stars. The resulting explosion is known as a kilonova. A neutron star is the burned-out core of a once giant star that exploded long ago. This particular pair was initially separated by 200 miles but spiraled towards each other so rapidly that they met 100 seconds later. Situated about 130 meters light-years from Earth, each neutron star was around 12 miles, 19 kilometers, in diameter and contained a mass about 500,000 times that of the Earth. The final moments of their spiral and the actual collision itself generated the gravitational waves. These were detected at 1:41 p.m. UK time on the 17th of August by two identical detectors in the US, Washington State and Louisiana, and a third detector in Pisa, Italy. It triggered a worldwide alert for other astronomers to try to find the event with traditional telescopes. At the time of the first gravitational wave detection in February 2016, there was talk about how this was the equivalent of a new sense for astronomers. Being ripples in the fabric of space, gravitational waves were said to be rather like the cosmological equivalent of sound. It would be like going from silent movies to talkies. This is now coming true because at almost the same time that the gravitational waves were discovered, NASA's Fermi Observatory registered a short burst of gamma rays. Such short gamma ray bursts have been known about for years. Analysis suggested that they were the result of a collision between two neutron stars, but clinching evidence has always eluded astronomers. Until now. The gravitational wave signal shows clearly that they were neutron stars, not their larger cousins, black holes. Follow-up observations taken with ground-based telescopes captured the flash of the explosion and showed astronomers the chemical fingerprint of the atoms in the debris, including significant quantities of gold. This mixture of gravitational waves and traditional observations is the opening of the astronomical floodgates. Such coordinated observations are going to become the norm for astronomers. And as they do, expect more wonders and more links to be found between us and the wider cosmos.